first question, which says that a hollow circular cylinder, open at one end, is constructed of thin sheet metal. Total external surface area of the cylinder is 192 pi. The cylinder has a radius r, height h. Express h in terms of r. Show that the volume of the cylinder is equals to this. Okay, so we have a cylinder open from the top. Okay, and height is h and radius is r, and we're given the formula, we're given surface area of this cylinder, which is 192 pi, and you must know the formula for surface area of the cylinder. It will not be given in the formula sheet. That's going to be the area of the bottom circle, pi r square, plus the area of its circular part, which is 2 pi r h. We will not include the top circle, otherwise it would have been excuse me, 2 pi r square. Okay, equals to 192 pi. We have to make h the subject, so it's going to be 192 pi minus pi r square upon 2 pi r. This gets divided. Okay, equals to h. Now we can take pi common in the numerator and then cancel it with the pi in the denominator. So we'll be left with 192 minus r square upon 2r. Okay. Now we need to find an expression for the volume, which looks like this. So volume of a cylinder is pi r square h, another formula that you must have memorized because it will not be there in the formula sheet. Replace h with the expression we just got. Expand completely this r, and this r square gets cancelled. Then you open the brackets, you get uh, half, I'm bringing out the 2 in the denominator, half pi, and then 192 minus r squared, and also there was an r outside which gets multiplied with the values inside, so 192 r minus r cube. Okay, so first part is done. Given that r can vary, find the value of r for which volume has a stationary value. Okay, so if the volume has a stationary value, that means it's maybe a maximum or a minimum. Okay, so let me show you what they mean. So if you look at this equation, you'll have volume on the y-axis, radius in the x-axis. So maybe the graph looks like this. Maybe the graph goes like this, or maybe it's like both, maximum at some point and minimum at some point. Anyway, they're asking find the value of r where it has a stationary value. So maybe they're talking about this, maybe they're talking about this, but we know if there's a stationary value, then dv upon dr must be equals to 0. So that's what we'll do. We will derivate the expression for v with respect to r. Let's do that here. So I'm going to first completely expand it. This is going to be 192 upon 2, which gives 96 pi r minus half pi r cube. Now let's do dv upon dr. That's going to be 96 pi minus 3 upon 2 pi r square. Okay, equated to 0. Now we have to find the value of r. So 96 pi equals 3 upon 2 pi r square. Pi and pi gets cancelled. 96 times 2 divided by 3 is 64 equals r square, which gives r is equals to 8. Although it gives plus minus 8, but radius cannot be negative. So we only choose r is equals to 8, which is the answer for part 2. So this was the working for part 2. Now they say find the stationary value. Okay, so find the stationary value means that you know that r is equals to 8 gave us this maximum, or maybe it's a minimum. Now you have to find the value of v. This is what they mean that by find the value of r for which v has a station. Okay, no, that's done. Find the stationary values. So finding the stationary value means they now want the corresponding value of v when r is 8. So we can do that by simply replacing uh, the the r with 8 in the formula. So v equals half pi 192 into 8 minus 8 cube. Substitute this in the formula and you get 512 pi. I've chosen to give the answer in exact form since the question is not specific about it. You could have given it in decimal form as well. Okay, so find the stationary value done and determine whether it's minimum or maximum. Okay, for this, what do we need to do? We have to tell that the stationary value that we got, where R is 8 and V is 512 pi. So maybe this value, and it was 8 comma 512 pi. Is it a maximum or a minimum? And what's the check of telling if it's maximum or minimum? You double derivate, substitute the value of x, that's going to be the value of r in this case, and if it is positive, then it's a minimum, and if it's a negative value, then it's a maximum. Okay, so I'm writing dv upon d r again. That was half, no, what was that equals to when we derived it? We got half pi. I don't remember what did we get. 192 divided by 2. It was 96 pi minus 3 over 2 pi r square. Okay, yes. Now we derive it again. So we get uh, 0 minus 3 over 2 pi times 2 times r. So this gives us minus 3 pi r, and r is 8, so we get minus 24 pi, which is definitely a negative value, and hence the stationary value or the stationary point 8 comma 512 pi is maximum.